This is a brief video on a project. It's Devin Miller's project, and I was helping him a little bit with some of the parts, and I thought maybe I could help everybody by showing it. He's doing beam elements as a physics type problem right here, and you can see here we have a distributed load that's length 4 meters, starts at 0, and a concentrated load at 500 newtons at the center of the beam, and I want to calculate the two resulting pin forces. Okay, so normally I would have this input as user input, okay, that I've highlighted here, but here just to get started, I put in the beam length, I put in the force as, and the reason I put it in brackets is I wanted to let you know that this might be an array of forces or an array of distributed loads. Okay, so you see there's a 500, that's the 500 here, 400 newtons per meter. The force location is at 2 meters, that's right at the center. The length of the distributed load is 3 meters, and the starting location of this distributed load is 0. Okay, and that's the whole program right here, is to calculate all this. Everything else was done in subroutines, or what I call functions, what we call in MATLAB functions. Okay, the drawing of the distributed loads, the drawing of the beam, the figuring out of the moment and forces for the point loads, the moments and the forces for the distributed loads. If I run this, you see I get my beam, and then I get my results over here. Reaction 1 is 1,000. Reaction 2 is 700. So if you just come back up here and you say I've got 4 times 400, or 3 times 400, that's 1,200 newtons forcing down, and 500 newtons, that's 1,700. So it does check out, but I've done a bunch of different analysis here. But let's take a look at each one of these. The drawing of the distributed load is drawing this green box. The drawing of the beam is drawing the beam and the force here, and I have this done. That was probably the most work in all of this right here. That's the drawing of the beam. This is the drawing of the distributed loads, and notice that each time I refer to this in loops so that I can put in multiple distributed loads and multiple forces. Okay, and it still works just fine. Then here is where I calculate the point loads. Okay, here's the functions for the distributed loads, which calls point loads. Okay, it converts the distributed load into a point load and then calls point loads. And then here's the function that actually does the solution, which is quite simple. Okay, so it was a little bit of work, but not too bad. Okay, just quickly, I'm going to change this. I'm going to put 2 distributed loads just to show you that this will work for 2 distributed loads. Let's put a 250 pound, or let's make it 300 pounds. That way it'll come out to an even 2,000. And let's put that location at 3. Okay, let's run it again. And you can see it put the other force in here. And then when it calculates out, I get 1075 and 925, which comes out exactly to 2,000, which is what I would expect.